spinning at just the right rate, it has to be at just the right height, it has to have just the right weight, and the temperature has to just be very, very finicky. Okay? To demonstrate how finicky it is and or how bad I am actually doing it, I'm going to ask Ben to have a go. Ben, do you like how it goes, right? So what you need to do then is you need to stand the top on there and then spin it just like that. Whoops, sorry. You need to put it on the base there, spin it, and then raise it very, 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 very carefully until you get to the right spinning height, and then you just pull the base downwards. And there you go. Right, simple. There you go. My friends, get it on straight. Whoops.
There's nothing odd about this either, in the sense that there's nothing about this that intrinsically makes it levitate to midair. It's like dropping like anything else. Okay? This, though, is not magnet, as you can tell. This is a copper tube, though, and it's not magnetic. Okay? So, copper's not magnetic, and I'll demonstrate that by doing that. But if I drop this thing down the copper tube, right, I want you to count loudly if you want. If you want to pretend you're 10 years old, you can count loudly and sync with each other. If not, you can just count in your own side of your head. See how long it takes for this thing to come out. Ready? 1, 2. It takes quite a while. There are two basic problems it has that are made use of in labs, in homes, in technology. What does it do?
Conducts.
It conducts heat and electricity. The big clue about that is that the link there is that electricity is the base of all magnetism. And what this is doing is it's generating an electric current, and that generates a magnetic field which pushes this up. Pushes it enough to sort of hold it way down. I mean, if you had something like that going on around you when you jumped out of an aeroplane, you wouldn't need a parachute. You jump out of an aeroplane with this sort of device around you, and you can land safely. There are such things. They're called superconductors, and I'm going to show you one right now. Okay? The trouble with it is, they only do what they do when they're very cold. This one is known as a high temperature superconductor, and high temperature actually means it needs only to get to minus 196 degrees C, which turns out to be in the superconductor high. But actually we can access that kind of temperature using liquid nitrogen. The main constituent of there, or effectively liquid air. The trouble with the liquid nitrogen is, it's that cold that if I were to touch it with my bare hands, I'd get frostbite. And I don't want frostbite, so I'm going to put these big teddy bear gloves on. And I'm going to, just to illustrate to you how cold it is, I'm going to take a flexible rubber tube here, coil it up like that, and normally if I were to, just let go of this, it would scream. But if I put that in this thing here, you see what's bubbling? There's a little bubbling going on. Suddenly I am putting a very warm thing in that liquid nitrogen there. Remember, it's at nearly minus 200 degrees C, okay? If I take that out, it's not quite stopped bubbling. It's completely rigid, okay? It's frozen, it's solid. And I can't actually shatter it. Okay? It's rigid, it's brittle. So that's how cold it is. But what I'll do now is I'm going to put my goggles on, right? And if one of you wants to have a go at this at the end, I'm sure that will be possible. I'm going to pour this liquid nitrogen into this little petri dish here. Ready, steady, go. And there are all kinds of bubbling going on. There we go. The bubbling is because it just came into contact with something that's about 200 degrees hotter than it. Okay? I'm going to take my gloves off now. What I want you to watch is what happens to that little magnet that's sitting on top of the bigger disc. Okay? Nothing much is happening yet. It's sitting on it. Watch. It's now levitating. It's now in midair. Just to show that it's in midair, what I'm going to try and do, can you see? It's actually in midair. There's a clear gap, no strings attached, as said in the title, that we have delivered. If I take this piece of paper and make it rigid, this no spinning, this stable, no spinning levitation that we could make fantastic use of. This is what, if we had this in our railway tracks, if our railway tracks could be made with stuff in that disc at the bottom there, we could have levitating trains. The trouble is at the moment we have to bathe our entire railway track in nitrogen, and that won't do. So we've got scientists working on this problem, and they have been working on it for nearly a century now. Where are the materials that would do this at room temperature or outside temperatures? If one of you became that scientist and joined the team that made that discovery, you would be remembered for years and years to come.